Right. So just there this morning, I've put a new set of slides up on Moodle. We're still dealing with version control. And today I want to talk about the area of branching in relation to Git. So it's going to be all talk this morning, no demos, unfortunately. But let's try and get through it. There will be a lab next week. All right, 2 labs actually, which involve branching. So we've that to look forward to. Now, so branching is extremely important when you're working with a team. So it's part of that whole kind of collaboration support aspect of what this module is about. Because if you're working in a team and you're working on some particular part of the application, some task, you may be committing to your work as you're working your way through it, but it's incomplete. And so you don't want any of your work to potentially impact on other people in the team until your work is completed and a decision has been made to include whatever development work you've been working on. It should be included in the overall application. And so the way we can ensure that whatever code we're working on doesn't impact on other people is through this branching idea. But even if you're working on your own on a project, branching is really a good strategy to have as well. If you're doing some development and it's just not working out and you want to get back to an earlier stage before you started whatever experimentation you're working on, then branching just makes that rewind much more straightforward for you. So it's beneficial in both contexts. Right. So what is a branch? I'm saying a branch is when you divert away from what I'm calling there just the main line of a project's evolution. We use the term master to refer to the main line of development. But if you go in, you create a branch, and we'll see how you do that, and you do your development work and you do your commits to that branch. Eventually, you may want to merge the branch back into the master. That's another common task that you will do and that Git will do for you. Git will support that to the best that it can, but it may leave some of the merge work up to you because obviously Git doesn't know anything about code or anything like that. So when should you create a branch? When should you use them? Essentially, no matter what you're doing on a software development project, when you're embarking on some new task, whether the task be developing a new feature, doing some refactoring, debugging, or just experimentation, and that pretty much covers everything really, then when you're embarking on any one of these activities, the first thing you should do is create a branch and start working on the activity. And then when you're finished the activity, if you want to, as I said a moment ago, if you want to include the work that you've done, then you do this merge, carry out this merge operation. So this kind of is your workflow. And this is irrespective of whether you're working on your own or in a team. You're following this branch, edit, merge workflow, which we'll do in the lab next week. Now, we know a little bit about the internals of the Git repository. It consists of all of these objects. And so what I'm sort of representing here is, this is these are commit objects, and each commit object is pointing at a mini network of tree and blob objects. So we've got some sense of that from this week's lab. So what is a branch then in this kind of low-level context? A branch is simply, I'm saying, a pointer to a commit object. Okay, it's a pointer, and really what we'll see is that a branch is a physical file. Everything boils down to being files and folders at the end of the day. So a branch is going to be a simple file that contains one line in it, and the line in it will be the SHA-1 hash value of a commit object. So when you create a repository initially, there is always one branch, a default branch called the master branch that just exists there. And if you don't use this branch edit merge workflow, then every time you perform a commit, then we say you are committing to the master branch. You're extending the master branch out every time you do a commit. That's the case, I'm saying, unless you create another branch. And so this is our kind of visualization of it now. Here we've got this pointer file, and what it's pointing at is it's pointing at a commit object. And this pointer file is the master pointer file, because that's the only branch that we have initially. So far, so good. When you type the git status command on the command line, which we talked about the last day, the very first thing it will tell you, if you look again at the output, is it will tell you which branch your working directory is aligned with. And if you're not creating new branches, then it will say something like this: you're on the master branch. Being on the master branch means that if you do a commit, then you are committing, we say, to the master branch. Or if I go back to the previous slide, you're going to create a new commit object over here, and the master file, the master branch file, is going to be pointing at that new commit object. That's what happens when you perform a commit, or that is an additional thing that happens when you perform a commit. This master branch file is updated, if you like. This is assuming now that you haven't created any other branches. And so that's how Git knows which branch you're on, it somehow knows which branch you're aligned with. We find out in a moment how it knows that. So as I was saying, everything finishes up being files and folders at the end of the day. So physically, a branch is represented as a file. And if we look at dig into the internals of Git, now you might think it's going to be somewhere inside in this folder here. It's not. I think this folder is actually redundant in Git these days, but there is a refs folder, and inside in the refs folder, there's a subfolder called heads. And in there, you will find the branch files or branch pointer files. At the moment, it looks like this particular repository only has a master branch. And if we looked inside that master branch, that master file, then you'd see something like this. And this is a SHA-1 hash. And it's going to be the SHA-1 hash of one of the commit objects in your repository. What I'm about to do now, please don't do yourselves, because if you accidentally edit one of these branch files, then you're going to corrupt your repository, and it's pretty much impossible to recover from that. So what I'm actually going to do is I'm going to pull a repository. This is just a random Git repository that I have. I pull that into VS Code, and as I said, please don't do this. Or if you do want to play around with it, do it with a repository that you don't really use anymore. And so if we dig down into the refs folder, refs heads, and it looks like in this particular repository, I've got a couple of branches, and I can just look at any one of them. And yeah, it's got a SHA-1 hash. And if I use the git cat file with that hash value, then it would tell me it's referring to a commit object and all of that. So that's what's going on within the Git repository in relation to branches. That's how it represents them. But, okay, I've shown you, but apart from that, then you don't need to get too involved in it. How do I create a branch? Surprise, surprise, there's a command called git branch, and you follow it by the name that you want to give to the branch. And that can be hyphenated. There's no real restrictions on naming, other than you can't have spaces in it, obviously. Now, the effect of this command is minimal, really. All it does is it goes away and creates a new file in that refs head folder with this as its name. And the hash value that will be put into that file will be the hash value of the last commit that you did to whatever branch you're currently aligned with. And let's just assume it's the master branch. So, this is how we can visualize it. We now have two of these branch files, and they're both pointing at the same commit object. And that's fine. This is kind of a proof. Again, this is a just cut and paste a sequence of commands that I submitted from my command line from my terminal. So I'm doing a git status. It's telling me I'm on the master branch. Then cat is just a command that's available to you on Mac, and it's just displays the contents of a file. So I pass this particular file path to cat, and it comes back with that. So that's the hash value of the last commit that I made to the master branch. Then I create a new branch, and I do a cat on that branch file, and the hash value is the same as this one up here. So that proves that the new branch that's created initially, it's pointing at the last commit that you carried out on whatever branch your working directory is currently aligned with. When I do git status again immediately after that, notice I'm still aligned with the master branch. So this command has had very little impact. It has had no impact on my working directory. And if I'm still aligned with whatever branch I was aligned with. Now, there is another special file within a repository, within a Git repository called the head file. And the head file, it contains a reference to the branch file that your working directory is currently aligned with. So if I go back to my repository here, and where's the head file? Boom, 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 boom. There it is there. And if I look inside that, that just contains the path name of one of my branch files. And at the moment, it looks like the particular repository that I'm showing you, my working directory is aligned with the master branch. So, and it's this head file that is actually what allows Git to work out, well, which branch is your working directory currently aligned with. It essentially looks for this head file, and that gives it the answer. So when we type the git status command, which we've seen a couple of already, if I just go back to this one, when I type the git status command, what Git does is it digs out the head file within the repository, and that allows it to make this statement here. So this is my visualization of head. Head now is a file. It contains a reference to one of the branch files. In this case, it's referring to the master branch file. And so when if I do a commit now, new commit object is created here. Master is now pointing at that commit object. Head hasn't changed though. Head is still just going to be pointing at the master branch file. And then this is just another kind of proof of that. If I do a git status, it tells me I'm on the master branch. When I do a cat on the head file, it tells me, yeah, you're aligned with the master. So let's paint a scenario. And this is Maria, the scenario. So what I'm trying to represent here now is I've done a couple of commits. My master branch file is pointing at this commit and head is pointing at master. That's the current status of my repository. Then I'm saying, suppose we want to do some experimental work, which we would do on a separate branch because of the reasons I mentioned at the outset. So I do some experimental work, commit it, but without impacting on the master branch. So that's fine. That's my objective. First thing I do is I create my new branch, call it whatever you want to. And this statement here is how you essentially change to or switch to another branch. And by switching to another branch, that will impact on the head file that I've been talking about. But this is the command, and then we talk about checking out a branch. Okay, so the effect of this now is I'm now aligning my working directory with this branch. And so if I do this kind of stuff here, I make some changes and I stage them, and then I do a commit. Now, this is what my repository, we can visualize it as. Okay, so here's the new commit that I've just carried out. Experiment is pointing at that commit and head is pointing at experiment. Why is head pointing at experiment? Because of this line here. So far, so good, I think. And if I keep on committing, my commit objects are going to be streamed across here. Experiment is always going to be pointing at that, and head is going to remain pointing at the experiment branch file. So this checkout command that we use to switch from one branch to another. If I just go back to the previous slide. So let's supposing this is my repository status. If I now do a git checkout of master, head now is going to point at this guy, but we said that we want our work, well, it's not that we want, but our working directory is always going to be aligned with whatever branch where head is pointing at. Okay, so when I did the commit here, my working directory was consistent with whatever changes were made by this commit. Okay, and then I switch to a different branch. So the effect in here is that its head is going to be pointing at master, but the changes that you made, the changes that you made here should now not be reflected in the working directory because they weren't part of this commit. So when you do a git checkout to a different branch, your working directory is effectively overwritten by whatever the status of the repository was when you committed to that other branch, when you last committed to that other branch. And that's kind of what I'm saying here, right? It does overwrite your working directory when you use this git checkout command, potentially. Fortunately, though, Git won't allow you to use this checkout command if you happen to have modifications or new files in your working directory that you did not commit. So you can't really lose any work as such. It will only allow you to use the git checkout command. In other words, to switch from one branch to another. It will only allow you to do that if your working directory is, as we say, clean, which means there are no uncommitted changes in your working directory. This is a shorthand command, the git branch, this command here, git checkout -b branch name. That effectively is creating a new branch and switching to that branch. So it's the same as issuing these two commands. It's just a shortcut, really. So here, scenario, git checkout master. Okay, so I switch to the master branch. The git branch command on its own, it will list all of the branches and it'll put an asterisk in front of the current one. So given that I've just switched to the master branch, when I issue the git branch command, that's confirming, yeah, your working directory is currently aligned with the master branch. Then I create a new branch called branch X, and I switch to that. You can follow me now. Okay, so I create this branch X and I switch to it. I do some work, and specifically, I'm saying what do you create new branch? All right, I mean, that's okay. Supposing I edit file A and file B, and I stage and commit that work. Okay, so I've made some edits to file A and file B, and those edits are committed, but they're aligned with branch X. So my working directory is now clean again. I'm going to switch back to the master branch. But by switching back to the master branch, it's going to overwrite my working directory, which in this particular scenario means if I look at file A or file B in my working directory, having done this, then they won't have the edits that I've just performed, because I committed these edits to a different branch, to branch X, and I switch back to master, so they won't be there. And that's kind of confirmation that when you switch branches using the checkout command, fortunately, there's no git switch command, but using the checkout command, your working directory is overwritten or changed. If I want to see the file A and file B edits, then I just simply do a git checkout branch X. And now my working directory has the edits in it. And I've mentioned this already. Git prohibits switching branches if your working directory isn't clean. Diverging branches is a common occurrence. So again, we've got a scenario. I think we're sticking with the same Git repository, Maria, the one with the master and experiment. So suppose after committing changes to the experiment branch, we then check out the master, make some modifications, and commit them. So visually, my repository might look like this now. I did switch the master branch, so head is pointing at master, and I did some work, as I said here, and I committed it. So the edits and the modifications in C5, obviously they're not available in C4. So essentially these two branches now are going off on sort of in their own direction, or they're diverging away from one another. They do have a common ancestor though, which is significant. So the two branches are evolving independently, yeah, although they have a common ancestor. So potentially what we will want to do now is we want to bring these two branches together to merge them. Maybe the work that we've been doing here, we're happy with it, and we want to make it part of the master branch so that everybody else can see it, if you like. So that's fine. Typically the work is either merged into the master or it's discarded. So I think we're taking a slightly separate scenario here now. So I've got customer that has recommended a new feature for your deployed web applications. Okay, so slightly different scenario here now. Here's our repository, master is pointing at C3. C3 contains the version of my web application that my customers are using. Somebody has recommended a new feature that we should develop, and we start developing that feature on a separate branch. And that's the status of it so far. We've made 2 commits to it. Yeah, so let's assume and that's often the case really, we're assuming that the master branch contains the version of my web application that my customers are using, as I've already said. Now, so we're working away on this feature, but what are we saying here now? A bug has actually been reported on the version of the web application that my customers are using. And straight away, obviously, we want to try and resolve that bug. That means create another new branch. So now I've got a bug Y branch, and we're trying to fix the error in it. Again, this is a very common scenario. We want to try and get all this stuff back together into master, so that both the bug fix and the feature, if we decide to hold on to it, is all part of the next deployment of, or the next version of my web application. So the bug fix work is completed, and it must be merged back into the master so that my customers can access it or have it. So how do I do that? How do I do the merging? So if you can, if I just go back now, so the master branch is the branch we want to merge into. We want to merge, we say we want to merge the bug Y branch into the master. And when you want to do that, you must set your working directory to the branch that's being merged into, which in our case is master. So I git checkout master, and then this is the command that will merge the branch into the master. Now, if you think about it, this merge operation is pretty straightforward. Again, if I go back to the previous slide, merging bug Y into master is as simple as just moving the master branch file onto pointing at C6. So Git can actually do that for me. And that is possible because C6 is directly, as we say, upstream from C3. There's so it's a straightforward operation to merge these two. So this is what my repository is now going to look like. And as I said, all that has happened from submitting this command is Git just moved master onto that. That's referred to as a fast forward merge. And that's only possible if the branch that's being merged into the branch that you're merging into the master is directly upstream of the master. Now, if you want to, you can go away and delete the bug Y branch, which really just means delete the file. That's the command to do it, but we don't tend to do that actually. We tend to leave all of our branches because it's a truer reflection of the history of the project's evolution, if you like. I suppose the only time you might do it is if you were doing some experimental work and you decided to discard it completely, then you might get rid of the branch. But even then, there's no harm in just leaving them there. So this is where we're at. Master is pointing at C6. So I've just removed bug Y from the screen just for clarity. And we still got this branch down here. And let's say we do want to merge this branch into the master. It's more complicated this time though, because C5 is not directly upstream from C6. So it's not simply a case of moving this pointer to point to C5, because if we do that, then, you know, going back to the history of the master, it's only going to go this way. So we've effectively lost the bug fix code that we put into our application if we just simply move the master to point to here. And so in general, right, when you've got two diverging branches like this, what it means potentially is there may have been edits made to files on this branch and other edits made to the same files on this branch. And those two sets of edits need to be merged together. Clearly, Git cannot help you with that. But what Git will do is it will tell you where in the files those edits took place, and it will let you resolve them. So it's only when edits have been made on both branches to the same files. If there's only edits to file X on this branch and file X hasn't been modified at all on this one, then Git can do that merge okay for you. So for these kind of diverging branches, Git will merge as best it can, but if it finds conflicting merges or conflicting edits on the same files in two branches, then it will just tell you where they are, but it will let you resolve them. So we refer to that kind of situation as a conflicting merge operation. So this is what it will look like. Again, we want to merge into the master. So we go git checkout master. We do the same command to perform the merge, but you'll get a clear response back from Git telling you that there are certain conflicts. It cannot complete the merge. It will go as far as it can in the merge operation, but it can't complete it. So it'll tell you there are conflicts, and it'll tell you, so how do you find out which files contain the conflicts? If you do a git status, it will actually tell you something like this. You'll see something like this appearing, and you will go through that in next week's lab. And it's pretty self-explanatory, telling you that both branches modified a particular file. So when you carry out this git merge operation, what Git does is it essentially performs the merge in your working directory or on your working directory. That was the case in the fast forward merge as well. And so your working directory, always contains the result of the merge, if you like, which is why the git status command will help us. So it's telling us which particular files are problematic. And if you open up one of those problematic files, because it's in your working directory, then you see these kind of markers in the file. And it's essentially saying, look, this is what's in a particular part of the file, this is what the master branch looks like, whereas this is what the the feature branch looks like. And you've got to, as I said, you've got to decide how you're going to bring these together. You perhaps consult with the people that wrote the code here and the people that wrote the code here and decide which way should we go. And you've got to remove these markers. These markers here were inserted by Git when it was trying to do the merge operation. So you remove the markers, finalize what the code should should look like in this particular part of the file. And there may be other parts of the same file that contain conflicts as well. But you essentially clean out, remove all the markers and resolve the code. And having done that, you didn't need to kind of tell Git, okay, I have resolved the conflicts. You can now complete the merge operation. So this is what you do next. Okay, you edit the files, as I said, you edit the conflict files, remove the markers, and then do a git add, which is the staging of the files, git add -a, or just git add the specific file, and then perform a commit. And this commit is the final stage of the merge operation. And so having done that, you know, this is how I'm visualizing my repository now. Head is pointing at master because we were always merging into the master. That doesn't have to be the case, but it was in ours. So head is pointing at master. Master is pointing at the commit that you've just done up here. And that commit now is bringing these two together. The difference between this commit and all other commits is this commit is actually going to have two parents. Normally, a commit object has one parent, as in all of the other ones on this slide here. But this has two. And so when you see a commit object that has two parents, you know it was created as a result of a merging of two conflicting branches. That won't be the case in the fast forward merge. It will just have one parent as normal. So this is all a bit, admittedly now, this is all a bit abstract until you actually do it, and that's okay. I appreciate that. Just checking my time, sorry. So that's essentially this branch edit merge, where the merge could either be a fast forward merge or a conflict merge, as we call it. It's only a guideline, but or a recommendation. What I'm saying here is not so much that you can't commit to the master branch, but the recommendation is that you should never commit directly onto the master branch. You should always be committing to other branches. The only operation you should be carrying out on the master branch is a merge operation. So if you're working in a software house, that's what you would notice. Nobody ever commits directly to the master branch. You can, but it's just considered bad practice. So you should only be merging in relation to the master. Which is what I'm saying there. And so, as I said, really at the beginning of the lecture, if you want to do any one of these tasks, then straight away try and remember, I need to create a branch first, and then I'll do my commits to that, and then I'll merge the branch back in. Now, we all fail on that every now and again. We find ourselves committing to the master, but the more you practice this branch edit merge workflow, the more it just becomes the normal way that you work with Git. This is just a slight, not so much a tangent, but just it's a nice thing to be aware of. So what's my objective here? My objective is that on the master branch, the commits messages should be a true kind of reflection of the history of the repository, or true, and it should be I'm saying it should be a searchable and meaningful history. So all of the commit messages should be very informative, which is back to the whole kind of communication purpose of the commit message. You shouldn't have commit messages, you know, that are just saying, there's still a bug in some particular part of the application. I did make a commit, but it's not complete, or I'm currently working on this feature, but it's not tested. The commit messages should never reflect those kind of statuses. They should always reflect something has been completed and fully tested. So that's what I mean by it should be a very kind of clean history. These are just the commits now on the master branch. The commits on the other branches, they may reflect incomplete work, and that's okay, because the rest of the team don't tend to look at the commit messages on the other branches. It's just the master that they're interested in. So again, I'm trying to paint another scenario. When you do a Git checkout, so I'm saying here, and we do Git checkout of my feature branch kind of from before, we do some work on it and we commit it. And let's supposing this is the commit message, and that makes sense. That's a good commit message. But then I find that when I do some just experimentation with feature X, it's actually buggy. There's some bug that I found in it. And so I do some work and I do another commit, and this is the commit message, just reminding me I forgot to include a certain part of the feature. And then I make another realization that there's a bug, and I fix the bug, and that's the commit message. Now, these messages here, we don't really want to see those appearing on the master branch. We just want to see the one that says the feature has been fully completed. That's it. But this stuff is real life. This is the way these are the things that happen when we are doing development. So is there some way that we can, now obviously the assumption as well is that we're going to be merging this branch back into the master, which I'm doing here. Am I doing it here? Git checkout master, git merge feature X. But now, because I've merged feature X, and feature X branch has all of these commit messages, these commit messages are now going to appear on my master branch, and we don't like that. So how can we avoid that? And the answer is you can perform what's called squashing of commits. So you can squash a group of development branch commits into one before you do the merge. So what are we doing here? We're doing git commit -a. Okay, that's the same as before. This is the first part of this squashing operation. Effectively, what I'm doing here is I'm rewinding the head pointer back. The 4 here refers to the number of commits that I want to rewind it back to. So essentially, the effect of this here is to remove these commits from the repository, but all of the edits that were done as part of those commits, all of those edits will still be present in your working directory. So it's as if you never did these commits at all, but you did carry out all of these edits. These are still reflected in your working directory. And so by doing that, we rewound all of these things, or effectively removed them from the branch's commit history. Our working directory now contains all the work. And if I now do a git state, git add, and git commit with a nice, clean, informative commit message, and then I do my merging, now the only commit message that's going to appear in the repository is this one here. But we still have all of the work that was done as part of that commit. So we essentially squash those 4 into one commit, and that's what appears on the master branch. And again, you'll actually do that in the lab next week. Now, there's lots of other kind of Git commands related to what I'm calling branch management. I'm just mentioning some of them there. As I kind of illustrated to you the last day, I find myself using VS Code's Git support more so than these commands, and things like creating branches and switching branches. You can do all of that quite easily. I'll give you a quick demo of it before we leave. If I just bring in a normal repository or a normal project, sorry. Unfortunately, there are edits which are that I don't want to have. Let's see. There isn't even a repository there. Sorry, there is. Let me try and pick out another. Let's see. Is that the one I brought in? With Git, what branch am I currently on? You just look down here at the bottom left and it tells you what branch you're on and how many branches are in my repository. So I've selected the Git active of the version control activity. And down here you can find stuff about branches. So looks like I've got a couple of branches. You can also find out whether the repository has a remote repository, as in remotes. No, I don't have a remote, but I've got these other branches. Now I can't switch branches at the moment because I've got an edit that hasn't been staged and committed. So I'll just do that for the sake of demonstration. X. So this is how I stage it, and these don't have commit messages like that. Now I'm still on the master branch, but I want to switch to another branch. And so all I do is bring up my branches, and you can see this little icon here. So if I want to switch to the EXP1 branch, click on that. And you can see down here now, I'm currently on that branch. So that's how you switch branches using VS Code's support. And there are other ones as well. A lot of them I haven't actually played around with, but presumably this is for creating a new branch, et cetera, et cetera. Okay, I'm kind of rambling on a little bit. Sorry about that. So that's branching, and we will play with branches next week in a couple of labs. Actually, we need about two more labs, I think, to complete the source control part of this module. Right, I'm going to leave it at that for today, and unless there are any questions, which unfortunately there usually aren't, but that's all right. No, all right. I'll talk to you next week. Bye.
See ya.
So.
Thank you.